Hello again. This is a short video to explain how to determine or calculate the empirical and molecular formulas. Well, the difference between empirical and molecular formula is the ratio. Empirical formula gives a simple ratio of elements present in a compound, whereas a molecular formula will tell you the actual number of different atoms of the element. So let's first calculate the empirical formula. So here you're having the elemental composition, which is given as percentages. That means in 100 grams of compound there is 40 grams of carbon, 6.72 grams of hydrogen, and 53.3 grams of oxygen. So we can assume this as the mass in grams. So the first step before you determine the empirical formula is to convert these grams to moles by dividing with the molar masses. So let's say the molar mass of carbon is 12.01 gram per mole, and hydrogen is 1.01 gram per mole, and oxygen is 16.0 gram per mole. So if you actually calculate these, the number of moles would be about 3.33 mole for carbon, 6.67 mole of hydrogen, and about 3.33 mole of oxygen. Well, since our data is given up to 3 significant figures, so I'm also calculating my moles up to 3 significant figures. So please do not, I repeat, do not round off your values of mole at this stage. Please don't round off. So these are our moles. So now to determine the empirical formula, you need to calculate the simple mole ratio. So how do you determine the simple mole ratio? Well, you divide the given moles by the smallest number, which is 3.33 here. That's 3.33. That's 3.33. So the simple mole ratio would be, we can say that is 1 mole of carbon. Here you can round it off basically, so that would be, when you round off, that would be 2 mole of hydrogen and about 1 mole of oxygen. So our empirical formula based on this mole ratio would be C, 1 mole of C, 2 moles of hydrogen, which will be shown as the subscript 2, and 1 mole of oxygen. So if the subscript is 1, I don't have to necessarily show that value. So the ratio is 1 to 2 to 1. Now the next step is to calculate the molecular formula. Now here it gets interesting. So excuse my straight line. Let me use a different color here. So to calculate the molecular formula, I have to first divide the given molar mass. So we have the given molar mass as 180 gram per mole. Divide that by the empirical formula weight. So the empirical formula weight of CH2O is about, let's say, that's 14.02, about 30 grams. That is the empirical formula weight. I'm rounding off these values. You actually can use your data booklet and come up with the actual number. So 30 grams is the mass of that empirical formula unit, also known as empirical formula weight. So if I divide the molar mass by the empirical formula weight of 30 grams, so I get 6 mole. So I multiply my empirical formula unit CH2O by this value 6. So if I multiply this empirical formula throughout with 6, that would be C6H12O6. I'm sure you're very familiar with this compound. That's right, this is glucose, the end product of photosynthesis, or the final product of human digestion of carbohydrates. Alright, so just let me briefly summarize how to calculate empirical and molecular formula. So you basically take the given masses in grams, convert them to moles by dividing by the molar masses, and once you get the moles, you calculate the simple mole ratio by dividing the moles by the smallest number, and you can round off your final mole values here. Alright, so that's how you calculate empirical formula. And then to calculate molecular formula, you can divide the given molar mass by the empirical formula weight, and then use that value to multiply the empirical formula unit throughout by that number, and that's your molecular formula. So this is your molecular formula, this is your empirical formula. So the difference is here you have the molecular formula gives you the actual numbers of moles of different atoms of different elements, whereas an empirical formula gives you the simple mole ratio of the different atoms. So that completes the video on empirical and molecular formulas.